So now we can see the relationship between sigma and rho. This term here is rho, so sigma divided by d equals rho. Or sigma equals rho times d. You can see this from units as well. We know that the units for this are coulombs per cubic meter, and the units for this are coulombs per square meter. So what do we have to do to convert these? We got to multiply this by something in meters. So it makes sense that the way to go from rho to sigma is to multiply by meters, so that these cancel. So then this would give us rho d over 2 epsilon. And what do you know? That's the same formula we got here, which in a sense maybe is a lot faster, or maybe at least on the test it would be a good backup to check yourself. I don't know if you would get full credit for just using the cookbook formula on the test. I think maybe they want you to actually draw the Gaussian surface and use Gauss's law. However, this is at least a good backup to make sure that you got the right answer. All right, so you can also just go to the handout and use the cookbook formula for plane symmetry, but you might have to convert from one type of density to another. So this would be another good thing to highlight in your notes, because this gives people a lot of trouble, how to convert from one type of density to another type of density. So I just wrote down the definitions of the two densities. And then, since I wanted to change this into sigma, I had to get rid of the volume and replace it with an area. And once I replaced the volume with area times distance, I could plug sigma into here and solve for that. That gives people a lot of trouble sometimes. So anyway, we confirmed that this would be the correct formula for outside. And if we were inside, then the volume enclosed would be A times 2x, as we saw before. So then sigma would be 2 times rho times x. And the 2's would cancel, and we would get this formula. I don't know if that's harder or easier. They both have some difficulties there. Okay, does that make sense? Yeah. Any questions? Okay, like I said, that's a good problem to try again. All right, and there's still one case we haven't covered, which is line symmetry. So we've covered how to do the Gaussian surfaces for plane symmetry and for spherical symmetry. There's also a case for line symmetry, but that's not the main thing your homework this week is covering, so maybe we'll come back to that maybe when we're preparing for the midterm and go on to the material for this week. Okay. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the info box. Thank you.